how does a soft starter works, what's inside a soft starter and its applications and advantages. Before starting, please subscribe to stay connected with this channel for some amazing upcoming video tutorials. To understand a soft starter, first we will see what's the difference between a direct online starter and a soft starter. If we start a motor with a direct online starter, the motor starts with a fairly larger starting current or torque current. Once the motor reaches its nominal RPM, the current drops to the normal rated amperes. When we stop the motor, the current suddenly drops and motor stops with freewheeling motion. Now, if we start a motor with a soft starter, the motor starts slowly from 0 ampere current and gradually reaches its nominal RPM. This reduces the starting torque currents and motor goes from 0 RPM to its normal RPM very smoothly. When we stop the motor, the current slowly drops and motor stops slowly and gradually. Now let's compare the motor current curve of the direct online starter versus soft starter. As you can see that the DOL starter starts with a very high starting current or the torque current. Once reaches the nominal RPM, the current drops to the motor rated amps. When the motor stops, the current suddenly drops to the zero and a motor stops with its own inertia. Now you can see that the soft starter motor starts and amperes starts to go up slowly and gradually. Thus, its RPM will also be increasing slowly and reaches its nominal current. There will be no starting torque or surge currents and the motor ramps up to its nominal current and RPM gradually. What's inside the soft starter? A soft starter is mainly a three-phase voltage regulator consisting of a set of trikes and the gate firing circuit. These trikes regulates the voltage and allow the current to pass through when the trigger pulse is applied to the gate of the trike. The amount of the current depends upon at which angle the gate triggering pulse is being applied at the gate of the trike. This firing or the triggering angle of the gate pulse defines how much voltage are being regulated and how much current is being applied to the motor coil. To bypass this trike circuit, there is a three-phase contactor which applies the full voltage to the motor coils. When we start a motor with a soft starter, controlled and regulated current is applied to the motor and motor starts to gain speed slowly and gradually. Once the motor reaches its nominal speed or at least 80% of its nominal speed, the trike turns off and stop conducting the current. On that moment, the bypass contactor turns on and full voltage applied to the motor and motor runs with the full power. When the motor stop command is applied, the bypass contactor turns off and cuts the current passing through the contactor. On that moment, the trike again starts conducting the current. And now the current is being applied to the motor via these trikes. This current drops to the zero gradually. This allows the motor to stop slowly. We can set the ramp up, which is the startup time, and ramp down, which is the stop time in the soft starter parameters. It depends on the application and the starting load on the motors. A soft starter is a solid-state device used with the AC electric motors to ramp up the voltage and the torque on the motor during the startup. This ramp-up voltage effect reduces the mechanical stress on the motor and the shaft, as well as the electrodynamic stresses on the attached power cables and the electric distribution circuit. The soft starter extends the lifespan of the mechanical system and reduces the maintenance cost. Soft starter are used as a replacement for the DOL starter and the star delta starter, mainly to reduce the starting torque currents. These soft starters can be used with the fixed speed running pumps, grinder, conveyors, mixers, and the crusher motors. That's the end of the today's tutorial. I hope you like it.